Hi, Rob.
Hi, good afternoon. I'm just going to lurk for the most part, but I'm curious about the topic. So,
Okay. You're joining from Shopify.
yeah, so I'm based in Toronto. I've been at Shopify for almost 5 years. We've been doing GraphQL for like 8 years and stuff.
Oh,
But
nice.
we generally just do our own thing, and as many people do. But try to get more involved in the community here and there. So,
Good. Hi, Trask.
Hey,
So we are still only half of the people that have signed up. Let's see. Who can I ping? There's Ellie. Hi, Ellie.
Hey, man.
Good to see you again.
Good to be here.
Okay, Bryn is not gonna join today, most likely. I just asked him Slack, and Valentine is gonna join a bit late, but then let's get started. Okay, so by being here, we all agree to the spec membership agreement, the participation guidelines, the contribution guidelines, the code of conduct, and all the things which are listed in the agenda on point 1. And as a note, this meeting is also recorded and will be published to YouTube. If you would not like to be published there, then you can either turn off the camera, or also, if you don't want your voice there, turn off the mic. Then second point of the agenda is introducing the attendees. We'll go in the order of the attendees in the agenda. So hi, I'm Pascal, and I'm from Chili Cream. Brian is not here, Valentine is not here, so there's Rob.
sure. Hi, I'm Rob. I'm based in Toronto. I work for Shopify.
Ali.
Hi, I'm Ellie. I'm based in Baltimore. I work for PayPal.
So then we have Trask.
Hey, I'm Trask. I work for Microsoft and work on the OpenTelemetry. I'm a maintainer in the OpenTelemetry semantic conventions.
Awesome.
And stepping away right now, I'm just rebooting coffee, so not on video at the moment.
Okay, great. Cool. Today we actually only have one agenda item. It's all based on the Excel that we started last time. And for Rob, I think you were not here. Is it the first time that you joined?
Yeah, this is the first time. I'm
Okay.
familiar with the subject matter a bit, but I certainly haven't seen the spreadsheet before today.
Right. Okay. So what we started doing last month is starting to define spans and attributes that we think would make sense in the specification in the semantic conventions, and we're trying to be very considerate about like cardinality, what really is required, what shouldn't be required, what's conditionally required, recommended, and so on. And we in the meeting last week, we have defined these four span attributes. And I think we should just continue the discussion today about other attributes and also about other spans, because at the moment we are more or less thinking about the operation span, but there's probably more which is interesting in graphical. Hi, Valentine. If you don't mind, because of background noise, you either mute or unmute yourself when you want to speak. Great, thanks. Okay. We also did talk about errors quickly last time. We pushed this back a bit because that's something that we can tackle later. And also, it's a bit. Trask explained to us that it's a bit in shift in the OTel specification how errors are reported, so exceptions and stack traces and so on. And I believe that Utra said that you might be able to get some more information about what the future of this will be regarding the errors, if I'm not mistaken.
Yeah, so one thing that has moved forward since last time is the supporting complex attributes on spans is moving forward. So that would give you the ability, I remember we were discussing your to have like multiple errors, like a list of errors captured. The bigger discussion around errors and exceptions hasn't moved forward because we've kind of bottlenecked on the complex attributes question. But now that that is mostly resolved, we're planning to get back to the errors and exceptions question in July.
Right. Okay, great. So then I would say we probably should postpone this once more and then just tackle it once we know more. But the complex attributes, I've read into it quickly last week, I believe. This means that in the attributes, you essentially can now encode kind of JSON, right? You have the key value pairs and you have the lists, and together you essentially can build arbitrary objects of any value, right?
Yep.
Okay. Great. Yeah, let's see how the discussion about error goes in the specification, because maybe we are able to reuse the official way of doing errors, and otherwise we just add a new attribute to it. What we could start discussing today is a bit the use case of having more than just an operation span, or if someone has other metadata, like let's first complete the discussion around the operation span actually. does anyone think that there is more metadata that we should put into the semantic conventions for an operation span, meaning for mutations, queries, and subscriptions? Subscriptions are a special case anyway that we have to talk about.
Sorry, zooming out one question would be, how about like life cycle things like lexing, parsing, stack validation? Do these kind of go into the umbrella of an operation? Because some of them are at like the document level versus at the operation.
Yeah, so this is something that we have to think about, where like metadata around the whole variable coercion, document parsing, and so on, how we want to include this in telemetry. At the moment, what we did in Hot Chocolate is we just have it as separate spans. Like we have a span type. This is the parsing span type. This is whatever. But I'm not sure if this is the right way of doing it, because essentially what we do is we cache the document. So as soon as we have we only parse the document once, and then we just have to hash. And as soon as we know we have to hash, we don't have to parse again. And also operation compilation, which most or some servers do. And this would then be a bit tricky, because essentially this means that you only have one span once, and then you never again have the same span. So that's a bit the question here. Trust, maybe a question about for you is, what's prior art here? How do other implementations do one-off things in the semantic conventions? So to give you a bit context here, when a graphical document arrives, it's just a string. And what then happens on the server is that you essentially have to parse this string. And sometimes you have to compile an object structure on the backend based on the string. And normally, like by the specification, theoretically, this can happen on every request, but most of the implementations obviously don't parse this document every time it comes. So when you have two clients that send the same document, we only do it once. And now the question is a bit, is there any other use case in OpenTelemetry semantic conventions that did that already?
So like caching, cache hit miss kind of stuff?
Well, it's interesting to know how long validation of a document takes, but it's an information that you actually only get once, even if the request is executed 50,000 times. So the question is the span, or are there other ways of doing it?
I'm not thinking of any prior art exactly. I mean, there's sounds a little bit also like prepared statements at a database level.
Yep.
I think we would generally capture that, if you want, if that's an interesting timing. I mean, first of all, there's metrics, right? But putting metrics aside,
You were
as far as
breaking
what
away
you
quickly.
it could be a nested span. That you just capture, that one time when the validation occurs. If you want, like on the subsequent requests, do you want to link to that? I guess I'm not.
We could. I'm not sure if it adds value.
Yeah, I didn't see it adding value either. I guess what do you want to capture? What's
Most likely duration. Ali, maybe you have an input. You have your hands
Yeah.
up.
I think looking at this from the idea of it only happens once per document, there are servers that implement that, but I know some of the very popular implementations of GraphQL don't by default. And so to me, this is still, we're tracking a piece of work that's being done with some attributes and timing. And sometimes in a request that is done and sometimes it's not. And if we were to just have a span for lexing, parsing, etc., right, like processing the document, whether it's spans for each of those steps, but like the point is that we're recording this, right? Just by having those spans there, we're then able to say, oh, this request did do that, this one didn't, right? What is the timing of it, right? So I think, like we cache a lot of things heavily if we're not doing the work because we cached it, right? We don't have spans for that. But when we do the work, even if it's something that only happens, right, it's synchronous within the request lifecycle, right? So even if it only happens once a day, once a year, right, like that's still some work that we did and we would track that on the trace.
So in that case, generally, we would lean into creating a specific span name for operation validation, and therefore most likely also for variable recursion, which happens on every request if you have variables and so on, just to see how this behaves. It could be recommended. It's not something that you have to implement.
Yeah.
But I also see the value, especially when we think about tooling. What we do in Niger is we analyze these spans, we pick them up, and then we at least know once how long the validation or the parsing of a document took, and then we can store that next to the document, right? We don't do it in every trace on every request, but when we have it, we can add this information. Question is a bit how many of them do we need? I mean, like without fixing names now, there would definitely be something like I don't know, graphical server documents validation, right?
So just wanted to mention one other option is just having a pure metric for those. And it won't give you correlation every time, but there are exemplars on metrics which do allow you to correlate some things, a certain number of those to spans, right? So that may be good enough, for example.
The problem that we have there a bit is the cardinality explosion, because just knowing generally how long a document validation takes is not something that is really valuable, because it's very, very document dependent. So we would have to link back to the operation ID or to the document ID, the hash. And then we have, again, the cardinality explosion of metrics, right? Because there we have definitely more than these, or not definitely, but it's likely that we have more than 1,000, 2,000 of operations that execute in big systems. So it
Yeah, another option.
Yeah, go ahead, sorry.
That makes sense. I was just thinking another option that I'm not sure if there's prior art yet, but I could definitely take it back to the semantic convention group and see if people are aware of, is if you think that nested spans are going to be too heavyweight for some of these things, is having an attribute on the span that just records the validation time, kind of like a metric measurement on the span itself. I've seen that in other systems. It seems a very reasonable approach as well.
To be honest, it happens once per request, and looking at the tooling around OpenTelemetry, it's actually quite nice to have it as a span from a visualization perspective. So we see the request start, then you see that there is validation, variable coercion, and then the execution starts. So that's actually quite interesting. The question is a bit where, like, it happens before the operation execution, right? So we definitely maybe have to think about what we do with this span, because at the moment, this is the graphical server operation, which might not be specific enough, right? Because like that's something that I maybe have to talk with or we have to think with Benchy a bit logically where it makes sense. So validation definitely happens before execution. And if I'm not mistaken, variable coercion also happens before execution. It's not part of the graphical query execution, but I would have to look that up. So that means that we actually have a couple of spans before the actual operation, graphical operation execution. So there might be a common.
Do you have a, I mean, that's where a parent span that captures the actual, assuming it's HTTP request, could come in handy because that'll tie them all together under the, and the HTTP request would give you sort of the largest section of what's from the start of the request to the end of the request.
Yeah. There could be potentially something which wraps the whole the whole execution, like not the execution, the whole graphical bit of the request.
And I think that's the common implementation of the operation span today, which is the operation kind of wraps all GraphQL stuff related to this operation, including parsing the document and whatever. Like it's looking at it as a request. At least the Node and Java contrib libraries do it like that. So I think if we're gonna move parts of initializing the operation, like validation and things like that, out of the operation span, then we lose that semantic, like, okay, we had a HTTP request that came in. It then became effectively a GraphQL operation after whatever web server stuff we might have been doing, right? So having the operation span as like a wrapper around all of the things related to that operation is nice right now, but I'm thinking we lose a little bit of that.
Like there is some ordering.
If we,
sorry, go
ahead. I just think we lose a little bit of like the meaning of that GraphQL operation span. If we start like following like how does the engine implement this as opposed to like logically what is going on here. Does that make sense?
I was just going to warn that sometimes there's this order of operation where it's like you want to put metadata on the operation span, but like you haven't yet parsed the document to like say maybe even pull the operation name off of the document. So that's just something to keep in mind about like sequencing of things.
Yeah. Yeah, the question is like, what's better here? So I have two examples which I can show, which actually show the difference quite nicely. So we're talking about this at the moment, right? Where's my sharing button?
And just for clarity, we want to be able to almost like independently have some tracing in the sense that like you don't always have static validation happening or you don't always have execution happening. So like whether it's all grouped together or not, maybe that's also like a client specific concern.
Yeah. Yeah. So it's about these spans, right? And where they are. So this would be the operation span, so to say, which spans everything. And inside of the operation span, you have shorter spans, which say how long the validation and so on picks up. The question is there any value in saying that actually we have another span here, which says this is the actual execution part of the graphical operation execution?
Is that different than the execution of the resolvers? So if I have an operation that executes 3 resolvers, let's say, does the operation, right, not that top span, is like, okay, we finished everything, now we're actually doing the operation block. And then from there we go and just execute those resolvers, right? Does that have some additional meaning that we're trying to capture?
Yeah. It's probably grouping all of the resolver executions together, right? At the moment, they're more or less free floating inside of this operation trace together with stuff that runs before the execution. So the question is if it makes sense to have one which encapsulates this all of this. I can second. I have an example here which does the same thing. Let me move this over to my different machine. That's now a bit sad, but
One point of clarification for the resolver spans, do they include scalar coercion?
at the moment there is we haven't talked about resolvers. Resolvers is it's also a very, very difficult topic, because if you trace all resolvers, then you're doomed. Right?
Yes, I have that problem right now.
Completely impossible. So we can touch on it once we have the operation bit done, and I can also explain how we make it quite. It has its downsides, but it's quite nice when you know if you have a sync or an async resolver, which in for example in .NET is very easy to detect, but in JavaScript it's very hard to detect, because in JavaScript you pay if you want to detect if your resolver returns a promise, you actually make the resolver async, which has a huge performance impact, right? So that's a bit of the problem there. But let me share this quickly. So it's a bit tiny, so sorry for that. But essentially, this is how it would look like when you have this resolver bit, right? So you have validate, you have analyze, you have this operation execution bit. Then you have the curse, and then you have an execution which spans all resolver executions. Now, does this add value or not? I'm not sure, but that's a different topic. It might be interesting for the tooling to know what the percentages are in these or in average, like take so much percentage to validate the document compared to its execution. But I don't know.
I think at least for us, we have. Sorry, go ahead. I was gonna say we have verbosity sampling, so sometimes it's like we want to trim out all the spans of the resolvers. So it is sometimes nice just to have that like higher level view, and you can drop all the extra metadata and not always have it emitted. But I think it's a very personal choice.
Yeah, I see. We can just note it down for later. But I think we're all in agreement that these actually add value to know that there was a validation and there was other spans, like this is hot chocolate specific, but variable coercion is GraphQL specific. That needs to run every time that you pass in a variable, right? Valentine, you want something?
No, I was just about to say that we are doing pretty much the same thing with an execution span that is the parent of everything that occurs during the execution of the operation, the actual execution. So after parsing and validation, you have one big span with everything in it, and it's easier to follow and to know what is part of actually part of the execution, particularly in gateway. When you have a gateway, you have lots of subgraph calls under it, and some are related to the actual execution, and some are not because they are, I don't know, fetching metadata or so things like that. So it's easier to understand what is part of the execution or not.
Okay. Ali, any comments?
Yeah, I was going to say, I think it's useful in terms of being able to correlate metrics with traces to have the separate validate ones, and then also, well, when we get to errors, but being able to identify errors from validation versus errors from execution, etc. Having those separate spans is definitely, I think a worthwhile thing. Definitely, at least as an optional thing. Like I think when it comes to verbosity here, optionality becomes important. But having a convention around that and being able to, for example, find traces where validation failed by some error is something that we definitely have a use case for.
I see that. I see that too. So then let's go back to the document here, and let's just say that we have the graphical server operation, which includes the graphical server document validation, and then we maybe have, or we most likely have something like graphical. I made the type somewhere. No, I did. So dot variable, something like this. And then maybe but that's maybe. But these two actually add value. So that's, is there anything else that we miss here in the pre-flight of a request? We could have the parsing also as a separate one, because validation and parsing are very different. So and also, yeah. Because the parsing is really dependent on the request document, and validation is dependent on the complexity, the semantic complexity of the document, and not necessarily the parsing complexity of the document. This is very document size dependent, and validation can be very dependent on what the hell do you do with nested fragments and whatever, like the usual suspects there, right?
In Yoga, I've also added a context building span. I don't know if it makes sense today because context building is sync in JS, I guess.
Well, this kind of is a bit it's very implementation specific, right? I mean, we know that in graphical a request has to be parsed, otherwise graphical doesn't work. Most graphical implementations have a validation because otherwise it would be very bad. And the variable recursion also has to happen. With the context building or the operation compilation or the execution plan, if you use a federated gateway, and all these kind of things are very valuable, but also they're not kind of standard. They're very different from, these phases are very different from each implementation, right?
Okay, so not in GraphQL.server directly. but perhaps something else than what we are defining here.
Well, it's not specific to graphical JS. It's more specific to any graphical server could implement these semantics, and then the tooling actually knows what to do with it, right? So the main reason why we do this is to avoid this, right, in the tracing system, because that's what we all fear and hate.
Because I was thinking about it because today I think about authentication and user validation, or at least authenticating and verifying tokens and things like that happens somewhere at the start of the HTTP request, and this is probably something that happens everywhere, but I don't know if it has a place in or GraphQL specific thing.
Well, you would it definitely has a value adding traces for this, but again, it's not really graphical specific. Like, it would do the same thing if you do a REST request, which means that like you could write semantic conventions for authentication, token fetches, and whatever, but they're not really graphical specific semantics, I would say. So also you don't necessarily need authentication, but that's a different topic. Okay. I can add a bit more description here and a bit more examples, what we actually mean by this. Is there any step of the core graphical that we have missed at the moment here with these spans? Okay. Yeah, so these will link back probably with the same attributes that we have, right? The name, the hash, and the ID. You need all three to know what, actually, not necessarily, but definitely the hash is important, or the operation ID in parsing, validation, incursion. Incursion, the name is also important. Okay. So maybe to just quickly, this will probably take also next work group meeting, but just to talk about it a bit, the hot topic about graphical server resolvers, or fields, or however you want to call these spans. They are dangerous, because if you just enable all of your fields to be traced, 99% of the fields that you have will just take a few microseconds to execute, because they are essentially just getters on an object in most implementations. And there are certain spans that are very interesting. For example, to see how long a field takes that a resolver takes that does a database query. It's also very nice to group these then database telemetry inside of a resolver trace, inside of the parent trace, so that you know that this database query was actually executed by this resolver. And this is a bit where we have to be careful, and also specification wise, then these attributes come into play, because at the moment we haven't really talked about them at all. I don't know, Ali and Rob, how do you do resolver tracing at PayPal and Shopify at the moment?
It's at PayPal, it's a little bit not standardized enough right now. Primarily what we're trying to do is trace most of our schemas. The important resolvers are like the first 1 or 2 levels. Beyond that, it's usually just, like you said, object getters. But a lot of the data fetching happens up front, and then you have, well, I said that a little bit wrong. You have the trivial ones that are just getters, right? And so we don't trace those at all. And then we'll generally trace about 2 levels of like resolvers that have actual implemented functions for them. But we don't have a way right now of differentiating between those async and sync ones. But even for the sync ones, we kind of care because they do things like currency formatting and stuff like that, which does blow up sometimes and throw errors. So it's good to know like that field consistently has internationalization errors from it. Yeah, I think that's about the best overview I could give of what we have right now.
For us, we're using OpenTelemetry, Ruby, GraphQL, Gem stuff. So we've been involved in the open source space there. But we do basically trace all fields, and then we have some verbosity stuff sampled out. So the problem you described is something that we do experience of like, we probably just trace too much, and like that's adding a lot of overhead and waste. We don't.
Sorry,
Go
go
ahead.
ahead.
Yeah.
It's not only waste that you generate on the OTel system, it's also much performance that you lose on the server implementation, right? When you have to write trace everything.
So like one of the things we poked at was like not tracing leafs or like scalars and stuff, and like being more aware of like the return type and like having some smarts there. But we tend to have, or in many cases, we have a deep graph, so we generally don't stop tracing after some depth. Just for people to follow, like I just post a link to the implementation in the chat, but we're poking at it to see how we can kind of have less instrumentation, because we just have too much instrumentation and that overhead is biting us a lot. And that's partly why I'm here.
Okay.
Yeah. It's interesting. I think, not to take this off topic, but something relevant is again how we report errors on resolvers. And when you use things like what do we call them? My mind is blanking right now. But when you have multiple resolvers that hit the same data source, and so
Data
that
loaders.
effectively gets data loaders. Yes. Right. So data loaders, when they return an error, we actually end up returning errors in all of the spans, and there's nothing that represents data loaders well. And so it just looks like every one of the spans, every one of the resolvers in your operation errored out. And so I think like
the nice push notification from the alerts that you had 2,500 errors, but it's actually only one operation that failed.
Yep. Yeah, it's like that one central thing that every one of your resolvers needs. So this is, I think the big question in my mind is like, what can fail? Like what matters, right? What has timing concerns and what can fail? And that's to me what we want to trace.
So on the topic of data loaders, I think this is something that we definitely should cover in OpenTelemetry, because my thing is always enable enough telemetry so that you don't blow up your telemetry system and you don't blow up your server, but do not enable too little, because then you don't know what's going on in the requests. And database traces for me are database spans are very important, so that you actually see that either it's a database problem, the complexity of the query is too high or the latency is too high or something like this, or it's a problem in your implementation where you see that the span of the resolver actually takes way longer than the database query, which is very short. So grouping that under a resolver trace, I think, is very valuable. The other thing is grouping the same thing in a database batch is also very important, because otherwise you have random resolvers which have traces attached because of context propagation in your code, right? So if you have a data loader, just one of the fields will have the database span attached and the other fields will not have the database span attached. And if you have this data loader trace, you at least know that, this is part of a data loader. So I think data load is something that we should add, but probably we have to tackle resolvers first. What comes up is what's important is the naming of the span. In our chocolate, we by default use the path, which is not always ideal, especially when you have nested lists which have async resolvers. So it actually gets also quite crowded there. What we do by default is we just trace everything which is a task, so which is async, which implies that you actually have a database that you have IO. Usually when you don't have IO, unless you have, as you say, Ali, like complicated calculations in the resolvers, usually nothing interesting happens there. And also the error rate is very low on these resolvers. I don't know, Valentine, you work with JavaScript servers quite a lot, right?
Yes.
Do you have a way to flag specific resolvers as traceable? Because by default, I believe in the specification, in the semantic conventions, and it's also something that we should note, is that resolvers should by default not be traced. They should be opt-in traceable, because otherwise the default will be horrible for most graphical servers to be used.
Yeah, that's what we are doing too. We have like an allow list of resolvers to trust, and we are using. You just provide a list of strings containing the path of weighted allowed fields. Like you have type name dot field name, and you have to just give the whole list of allowed fields, and you can also allow an entire object type, like you just give the type name, and every fields will be traced. At least it's how it's done for Sentry. For now, in OpenTelemetry, we just don't have any resolver tracing for now.
Okay. Maybe quick question to you, Trask. Is there any prior art in terms of something that happens? So for context, every field in a graphical request, which is essentially is a nested object structure, it's like JSON without the values, has a resolver. And as you can have lists and nested resolvers, the execution actually can get very quickly very complicated. So when you have a list of 50 users and each user has 5 fields, you would have 150 spans in your trace that you don't need, because the only thing which is interesting is actually the one with the database fetch that goes to the database. Is there any other semantic conventions which have similar problems? And is there already a solution for it?
So most of the semantic conventions today are around things that make network calls, HTTP, messaging, RPC, database, and as opposed to internal spans, which are what these would be. So client, server, producer, consumer spans. In the Java instrumentation, the stance that we've taken, because we do have some internal spans like around MVC, controller, execution, and we don't enable those by default. We just focus on the kind of the coarse-grained networky type things by default, essentially erring on the side of less spans, less instrumentation, and allowing people to opt in if they want more. We have had a couple of requests in the Java instrumentation for capturing spans for like every method call. And we say, hey, no, that's not tracing, that's profiling.
Mm-hmm.
I don't think that entirely is correct for you all, because I mean, you in profiling, you missed maybe the correlation of some of the names of things, because you only get function calls, but maybe, I don't know. But
I
yeah,
I haven't read into profiling, but you're technically, I'm not sure how flexible it is, because the open telemetry profiling that you guys start next, right, or are already working on. Does this allow for flexibility of like could we profile only GraphQL execution with it, or would this be all nested method calls and all these things as well? Because if we could profile a GraphQL execution, that's would be really nice for the stuff that you said, Rob, where you actually sometimes want to have all of the fields to know what's going on. So when you could say that we want to profile the GraphQL execution, you see every single resolver execution, but by default, you only see the ones that you specified in the traces, right?
so the profiling is sample-based profiling, as opposed to method probes, like capturing every single method call. It's going to be at like, one sample every millisecond, or one sample every 20 milliseconds, or whatever the interval you want, however much data you want to capture. And that is across everything. But you do the key part of the OpenTelemetry profiling is that it correlates the profile to traces, so that you can take a specific span and ask for the profiling samples and aggregate across those, to see your hotspots for that particular span.
Okay. Interesting. I'm really looking forward to this.
Yeah, I tend to push back on these like 150 100 nested span scenarios. I think it's fine as a debug option potentially, but it's gonna be, I don't see a whole lot of value in those in production, just because they end up just spamming you, noise, cost, all of that.
Yeah, 100% agree. The thing which is special in GraphQL is that anywhere during the execution, you might have something which is very interesting to trace. So as it's field-based, like you have objects with fields, which then have objects with fields and objects with fields. It could be that you actually have a database fetch at the root where you want to trace that this resolver took that long to execute. And then you have a lot of stuff that is not so interesting because it's just, object getter, setter, and so on. So very quick. And then deep in the tree, there might be a request that you do to a third-party API. And there again, it would be nice to actually capture this. Like this HTTP call was done inside of this resolver, because otherwise you just have a random HTTP call somewhere in your trace without the correlation to what actually started this HTTP call. So again, it's a bit a speciality in GraphQL, I would say, that it's not the root operation, the trace, which always correlates with what happens. It's what the user passes in. So it's more on a operations basis. So
like one
There
thing
is, oh, go ahead.
as you say, one thing we've been trying to experiment more recently with is like rolling it up. So instead of having this like relationship of one field to one resolver equals one span, is there a way to like merge that data and flatten it? So like you're kind of losing that like granular path information, but you can still roughly understand like this user object with this attribute or field somewhere in the tree resulted in like this larger time span and stuff. So like, and like to take that one step further, like we're almost like reevaluating our GraphQL execution engine of like depth first versus breadth first, and like not maybe having this like so many function calls happening and like having more of a batching style by default. So all I'm trying to say here is like right now I feel like the discussion we're having is very close to like that naive GraphQL JS, one field equals one function call equals one span, and that does have some relationship with like GraphQL data loaders and batching and stuff. So like they're not exactly independent conversations when you start talking about like merging information and like trying to flatten it. And do you want to flatten it? Should you flatten it? When do you flatten it?
Did you see Benji's talk about his execution, graphical execution engine
Real
thing?
fast, yeah.
GraphFast.
I talked to him yesterday actually.
All right. Because that's the same thing, right? Like the root of all evil are actually the resolvers. Like, is our execution model wrong? Maybe. Facts are that resolvers are and will be, like in most graphical servers, quite integral part of the execution. So I think we should add a graphical server resolver trace. And I also think that we should specify what attributes could be present on it. But we should also mark this as, like, don't trace everything. Like, there needs to be a note like, be careful with this. Like, don't enable it by default, because otherwise your finance team will not be happy about the bill that you have to.
So in the future, I dropped a link to a proposal, open telemetry proposal, which has been fairly popular. Sad that we haven't implemented it yet. I think it's very useful, which is context scoped attributes, where what you could do if we had this would be in your resolvers, you could add one of these you could add an attribute resolver name to the context, but not create a span for it. And that attribute, that context attribute, would propagate down. And then if you were making a third-party call inside of that resolver, that attribute would get automatically stamped onto that outgoing HTTP call.
Right. I see. So you would essentially tag the async operation but yeah, I know what you mean. You add metadata to the child of the resolver so that you know that it happens inside of a resolver.
Yeah.
I see. You need to read up on this. Quickly, Rob, Ellie, and so Valentine said they don't do any OTel tracing at the moment in their servers, resolver tracing. But you both do, right? And for me, we also trace, as said, all the async resolvers. And for me, it actually adds much value to see these details in a trace. Would you agree on that? Having a resolver trace is useful if you use it right, or
Yeah.
do we have
Yeah,
to?
like similar, I was gonna say similar to what you mentioned. Like if you can understand why a database access happened or IO happened, like it's just out there in the wild, and you're trying to attribute it to something triggering it.
And some of this might come down to like, what role should GraphQL play in making this easier? Like instead of hooking into, because most of the instrumentations that I'm aware of now hook into GraphQL, and when a resolver method or function or whatever runs, right, getting that information, because you kind of need that in order to start the trace. But there's another side of this here, is like, what if we were tracing the things that are just interesting? And that the challenge that we have at PayPal is there's usually like a certain level, right? When you get to a certain point in the schema, and like that's where we're doing our major data fetching. And then there may be somewhere later that we do some async data fetching as well. But I think we could sacrifice that second one for the first one, as long as there's some way to say, oh, if an error happened, it happened within this resolver, right? Or within this field. And I think we're overlogging for the ability to, when something weird happens, say, oh, it was within this resolver that it happened. And there's some level of granularity that we need in order to do that, at least, like I said, at the higher level of the query, whatever your first async level is. But yeah, I mean, this is the challenge of GraphQL. It's not just an open telemetry thing, but it bleeds into other things as well.
Yeah, no, I feel you. Okay, so we're out of time. I think it's we should continue the discussion there and next month again at what we want in resolver tracing and how we want to solve this. Again, like also Valentine, your comment, like yes, in distributed in federated gateways, there's most likely no resolvers that you want to trace. But still, like distributed tracing, it's quite nice to see what was going on in a subgraph call, right? So let's see where this goes. If you plan to join next month again, think a bit about what metadata we want to add to a resolver trace, and also what's the span name of resolver trace, because the path isn't ideal. So maybe it's just a coordinate, but it's a bit up to decide to us what we want to add there. Okay, cool. In that case, thanks for joining and see you later. Bye-bye.
Bye.
Attends, ah, si t'as fait regarder, je te les